Well, howdy, y'all. Welcome back to Multar Aviation. So, in this video, I'm going to explain what occluded fronts are. And so, if you haven't already seen my wave cyclone model video, go back and watch that as well. And make sure you subscribe. That way, you get notified every time I come out with one of these aviation weather videos. So, hey, I'm Dr. Andy Molter. I'm a flight instructor, a CFI IIMEI. I'm a former corporate pilot, and I'm a professor of aviation. And aviation weather is one of those classes I teach, and so you're getting a free college education right here on YouTube. All right, so there's two types of occluded fronts. There's cold front occlusions and warm front occlusions. So before we get into what the warm front occlusion is and what the cold front occlusion is, let's just talk about what a cold front, or I'm sorry, what an occluded front is. And so here on the left, we have this cold air mass, this cold front that's coming in, and it's catching up with the slower moving warm front. Now, let's actually go take a step back and describe what a cold front and warm front is again. And so we have we have a cold front. And so the cold front, you have this fast moving cold air mass that's catching up to a warm air mass. And when that occurs, this wall of cold air forces this warm air aloft, and that's where we're going to get like heavy storms, cumulonimbus clouds that extend high altitudes, like 40,000 feet. And so then a warm front is you had a relatively slow moving warm air mass that catches up to a cold air mass. And so that warm air mass, since it's going kind of slow, it just rides up and over this colder air mass. And the air is relatively stable. We have a temperature inversion, which, if you remember, that indicates stable air. And so we're going to get like stratus type clouds, steady precipitation. And so now that we know what the difference is between a cold front and a warm front, now let's go back into the occluded front. And so with the occluded front, we have our cold air mass. That's our cold front that's fast moving, that catches up to this slow moving warm front. And so just imagine this cold air mass wasn't here. You'd see just a regular old warm front. And then on the left, you got that fast moving cold front that catches up to the slower moving warm front. And so that together we call the occluded front. So now that we know what an occluded front is, now we can describe the difference between cold front occlusion and warm front occlusion. So a cold front occlusion occurs when a fast moving cold front is colder than the air ahead of the slow moving warm front. When this occurs, the cold air replaces the cool air and forces a warm front aloft into the atmosphere. And so when we have a cold front occlusion, weather is a mix of both warm and cold front weather, provided that the air is relatively stable. So this cold air mass right here on the left, this is the coldest. And then in the warm front, this is relatively cool air compared to this colder air. And then the warm air is warm. And so with the cold front occlusion, this cold front from the left comes in and it forces this whole warm front aloft. So this cool air and warm air go aloft, and you'll get a mix of both cold front and warm front weather. Then we have the warm front occlusion. So the warm front occlusion occurs when the air ahead of the warm front is the coldest, and it's colder than the air of the cold front. And so then what happens is the cold front rides up and over the warm front. And if that air is unstable, then the weather in the warm front occlusion is more severe than a cold front occlusion. And so this is where we can get some embedded thunderstorms, rain, and fog are going to likely to occur. So here we are, we're at the warm front occlusion. So this cold air mass on the left, this is the cold front. This is relatively cool compared to the colder air that's part of the warm front. And so since this air in the warm front on the right is the coldest, then this cooler air on the left, that's part of that cold front, that fast moving cold front, it rides up and over the warm front, and that produces the severe weather, which is worse than the cold front occlusion. All right, so hopefully you understand what an occluded front is, how it forms from the wave cyclone model, and you can describe the difference between the cold front occlusion and a warm front occlusion. And that way, when your instructor asks you about the different types of fronts, you feel comfortable asking or answering what these different types of fronts are. So thanks for watching this video. In the next video, I'm going to talk about dry lines. I know you've probably heard of them, but you're never really sure what they are. So make sure you subscribe. That way you get notified when that video comes out. And if you have any questions, leave in the comment section below. I read all my comments, and I'll answer them the best I can. So, all right, you have a great day.